So this is Math 26B. We're going to do a review of 26A today, some rules that I think you should know after we do the syllabus. So here's the information for the class. I'll try to set up our calendar so that the Zoom meetings are in the Canvas calendar. Here's my office hour info. And the prereq for the class is Math 26A or an appropriate high school-based class. Okay, the catalog description is just going over integration and applications of integration. Let's see. Let's go down to course materials. Okay. So there is a textbook. It's called Applied Calculus for Life and Social Sciences by Larson. You do not have to buy the book. I am asking that you buy access to WebAssign. I tried logging in myself and it looks like it cost $119. That comes with an ebook and it's the only item I'm asking that you buy for this class. Let me know if you have concerns about that. I just thought it was the best option for doing the class online. All right, so I'm going to explain WebAssign. Maybe we'll even try logging in a minute. But you would go to webassign.net, enter our class key. So you create an account, or if you have an account, you log in, and here is the class key. So this will lead you to our section of Math 26B. And once you enter that key, you should see my name. You should see, let's see. I've started a homework for you. I have to finish that homework. I always give you at least a week to do homework. So I've seen a few people, I saw that like 4 or 5 people have gotten their account set up on WebAssign. If you need help setting that up, let me know. I also have info from WebAssign for how to help you. I'll send that email out soon. So, WebAssign. Okay. So in these first 2 weeks, I know that we're setting up the class, we're setting up our online homework. So if you need an extension on homework, let me know. I can give you more time to do the assignments. And I also want to say that they give you a free trial. Start with the free trial so that way if you switch classes or change the class, you don't have to worry about that purchase. Okay, so I plan to do weekly homework. Oh, is the homework only access? I think from what I know about WebAssign is they give you access for, let's see, I think it's only for a certain amount of time. And I think it is just for this semester. I'll check the time. It used to be for a year, but when I was logging in this time as a student, it looks like it was until, from now until the summer. So I'll check how long access lasts. Okay. Let's do tests. So I plan to do 3 tests, an exam every 4 weeks, and then a final exam during finals week. Oh yeah, also by the way, there is no attendance as part of the grade, but I encourage attendance. Sorry for getting off track. So I encourage attendance because I I'm not always able to load the meeting right away, so I will record each meeting, but sometimes it won't be posted till the weekend. So if you don't want to fall behind on material, please come to class. Okay. Oh, that's right there. So, okay. Thanks for all the questions, everybody. If you're having trouble with WebAssign, I guess see me during office hour or write an email to me. We can check on your account personally. And oh, you don't have to join Zoom for tests. So, well, I wasn't planning on that. I was thinking of it as like a take-home test. It will have some strict settings, not as open as your homework would be. But I would give you probably a few days to do the test, and you can just do it on your own. You don't have to do it in class. Yeah, that's sort of the plan. Any other questions so far? Okay, cool. Yeah, if you have questions or concerns, let me know. I can try to work with you and make this semester as good as it can be. Okay, so here's how I plan to grade. I want the homework to be 15% of the grade. Each exam is 20% and the final is 25%. It's a cumulative final. It will be similar to the other exams, just cumulative. And any other comments? No quizzes in this class. Not concerned about that. Okay, here's the grade scale. It's kind of basic letter grade and final comments. Just want to comment about homework. I'll try to make sure you always have a week to do homework. And let's see. I didn't really, usually I would give a class maybe a week to do a test as well, but this class, let's see, this is 26B. I think we could do, this class I'm not too concerned about. Like, there's no 26C, so we're going to do, well, I don't know, is that true? Is there math 26C? Anybody? Anybody taking that class? I don't think so. So I'm not gonna worry too much and I'll say exams can be 1 week too. No quiz. Cumulative final. All right, I think that's it. So I'm going to do some notes for what you should have covered in 26A. And I think these things you should sort of have memorized or should be comfortable with. So I'm not going to do a ton of examples. When we meet next time, we'll go into like chapter 6. We'll do lots of examples and start homework at chapter 6. Okay. Okay, try to get some dry erase stuff. Try a different color. And so we want to go over rules for derivatives. Okay, the constant rule. So if c is a constant, or if c is a real number, c, the derivative with respect to x of c, so derivative with respect to x of that number c, the derivative of any number is 0. Okay, let's say c is the number 2. The derivative of c with respect to x, derivative with respect to x of the number c is 0. Okay, I also have we'll let f of x equal 4. And then take the derivative. So f prime of x is 0. Anything else? Yeah, one more. So example number 3. So 5. Doesn't matter. Okay, got y equal to 5. The derivative of y with respect to x. The derivative of y with respect to x for the number 5 is also 0. Cool. So next rule is the power rule. Oops. So I've got the derivative with respect to x of x to the n, so d dx of x to the n is n times x to the n minus 1. So bring down n, multiply with x. Okay, let's do just, I got f of x equals x to the 7th. Take the derivative of f with respect to x. So 7x to the 6th. 7x to the 7 minus 1. Okay, let's do another example. This time I let y equal x to the negative 3, negative third power. Take the derivative of y with respect to x, dy dx. Oh wait, let me make sure I have this written right. The derivative of y with respect to x is equal to the derivative with respect to x of x to the negative 3. Okay, so negative 3x to the negative 3 minus 1, so it's a little smaller. I think that's good enough. Let's go on. Okay. The constant multiple rule. Okay, so I have a function f and it's differentiable. So let's start. Okay, let f be a differentiable function. Of x and c is a real number, then okay, the derivative with respect to x of c times f of x is c multiplied with the derivative of f of x. Did I write that right? Let's do some examples. So I let y equal 5x to the sixth. We will take the derivative of y with respect to x. So d dx of 5x to the sixth. Bring out the 5 and then take the derivative of x to the sixth. Still going. So 5 times 6x to the fifth. Okay. How's everybody doing? Any questions? Cool. Okay. Okay. Let's keep rolling on through the rules. Oh no. Lost the class. Okay. We're going to the sum and difference rules. So we've got two functions, f and g. Let's see, f and g. We'll say let f and g be differentiable functions of x. Okay, so first, I've got that the derivative with respect to x of f of x plus g of x is equal to f of x plus g of x. The derivative of f of x plus the derivative of g of x. So you got this f prime of x add g prime of x. And similar for the difference. So if you have d dx f of x minus g of x, it'd be f prime minus g prime of x. So f of, let's do this. Okay, made it work. We'll do one. Oh, 30. Oops, did I miss something? Missed something. Yeah, if I ever make a mistake, let me know. Something, is it 30x to the 6th? X to the 5th. Thanks for helping each other. But it also stop me if I make a mistake. It might happen. It's probably gonna happen. Okay. Let's let f of x equal x to the 7th. Why not? So minus 2x plus pi. Okay, and then f prime of x. So this is just that power rule, 7x to the 6th. And then we go on minus 2. Bring down the power of 1, and then it's minus 1 from 1 has power 0. Okay, last part was a number, so plus 0, we'll just leave that off. More rules. So we have the product rule. Okay. F and g are differentiable functions of x. Assume that, or let f and g be. There's time. We've got time. Okay, we're going to put that here. The derivative of f of x times g of x. Okay, so let's just write it out first. F prime of x times g of x. And g prime of x times f of x. So it's the derivative of the first function multiplied with the second function, add the derivative of the second function multiplied with that first function. think we should do one. Let's try. We're just gonna keep moving through. I think we'll do some examples at the end, but let's finish up some of the rules. So product rule, quotient rule, chain rule. Okay, so it's a similar same kind of functions. Oh, sorry, I'm saying a question. Do we add C? Not yet. We're going to do that with antiderivatives. I just want to make sure we know what the derivatives are first. That's going to be chapter 6. When we do antiderivatives, we'll talk about adding C to the answer. So, good question. Always ask questions if you have one. So, f and g are differentiable functions. We want the derivative of f of x divided by g of x. So I learned a little rhyme for this. I'll go over that in a second, but the formula is g of x, f prime of x, g of x times f prime of x, subtract g prime of x times f of x. And it's all over g of x squared, or g squared of x, the same thing. It's g squared. Yeah. Also, as a side comment too, if you have any issues with the meeting, I hope that I'll be able to post the recording, and that way if you miss anything, you can just look back through the notes if you need to. Okay, here's the rhyme. So this function is down low, and this function is up high, and I was taught low derivative high, low d high, minus high function on top, derivative of low, and then square the bottom, away we go. That's the rhyme. So low d high d low, square the bottom, and then you're done. Or you could try to just memorize everything that's going on over here. Okay, the chain rule is so this is for the composition of functions. When you have a function inside of a function. So we need let's see. I just went straight into the derivative. So I have d dx of f of g of x. Let's write f composed with g of x, which is d dx of f of g of x of g of x. Okay, so just saying that this is f of g of x or f of g of x, having your function inside of a function, and you do the derivative of the outer function and then keep that inside function. And then multiply that with the derivative of the inside function. Well, let's wait on, I don't know. I want to do some examples at the end, so let's wait to do. Okay, we'll come back to this. The last two I want to go over are is just a reminder about the derivative of exponential, derivative of log, and then as a side note, you should know the derivative of some trig functions, like basic trig functions. I didn't have notes for that though. They should just be kind of like something you look up in the back of the book. I don't know, maybe some of them should be memorized. Okay, getting off track. Okay, so you've got u is a differentiable function of x. And we're going to take the derivative with respect to x of ln of u. So the natural log of u, this function, it's 1 over u times the derivative of u. Make sure I got that right. Yep. Okay. So I just put a note that the derivative of ln of x is 1 over x. Okay, last rule that I had planned for today is for exponentials. It's got a similar intro. See, I've got u is a differentiable function of x. Then we have the derivative with respect to x, d dx, of e to the u. Make sure I get this. It's e to the u times the derivative of u with respect to x. Okay, so before we do some examples, I'm thinking that aside from these rules, you should also be familiar with, let's see, if you had, let's say, I don't want to write this down. For trig functions, I would think you should know sine, cosine, and tangent. And I'm going to ask you guys for help on this because it's been a little while for me. I'm remembering that the derivative of sine is cosine. So correct me if I'm wrong. Oh, thank you. Nice. Oh, derivative of sine equals cosine or is negative cosine? Negative cosine. Derivative of cosine of x. Somebody? Cosine of x. Thank you. Derivative of tangent of x. Yes. Is it just secant of x? Nothing special there, right? Secant squared. That's what I thought. Okay. I think it's secant squared of x. I mean, if you had to, you can check your book. But when I was in this class, I felt like I had those memorized. Okay. Any other questions before I make up some examples? Okay, so I've got one ready. We have f of x equal to the quantity x to the fourth minus 1, and that all has power 7. Okay, so we'll take the derivative. We have a power rule / chain rule. So 7, leave the inner function alone, remove 1 from the power. So let's do 7 times power 6, multiply with the derivative of the inside function, 4x cubed. So let's see, got 28. Any mistakes? Anything? No. Let's try. Let's multiply some stuff together, like x is should be a little worse. Let's put e to the x squared. No, that's not ours. I'll be right back. Okay, just use the book. I won't keep you too long. We'll just do like 1 or 2 examples. So let's try. This looks cool. It's 3x over the root of 9 minus 2x squared. Okay, let's take that derivative. We have a I'm kind of wanting to change this function's name. I'm going to call this h of x. That way I can label this my top function, f of x. This would be my g of x. Okay, take the derivative of h with respect. Let's see. To x. Okay. Low d high, derivative of the bottom times the top. Minus high d low. Over the bottom squared. Ooh, this might take a minute. Okay, so we need to maybe rewrite this as a 1/2 power. So g prime of x will take 1/2, leave the inside, subtract 1 from that power. Power of negative 1/2. And then multiply by the derivative of the inside, which is -4. And then multiply with f of x. This is going to be messy. We want to subtract another piece, and this should all be in the numerator.
Professor?
Yeah.
It looks like we're taking the derivative of g of x twice. For the left-hand side, it looks like we're supposed to take the derivative of f of x.
You're right. Yeah, you're right, thank you. Try to put this better. Let's try this again. Oh shoot. Just lost the problem. It's like 9 minus 2x squared.
It's the square root of 9 minus 2x squared.
Yeah.
Okay.
Thank you. All right. So we have that root. Minus 2x squared. There's g of x times the derivative of f of x. Okay. F of x. And then multiply with the derivative of g of x, which we were just doing. It was 1/2 9 minus 2x squared to the negative 1/2 multiplied with negative 4x. Okay, that's all over g of x squared. So we're going to square that square root, which leaves the 9 minus 2x squared. Okay, that's right. Let's try maybe one more and then call it good. So. Thanks for being patient.
I just did have a quick question about the last one.
Yeah.
We did, sorry, on the right-hand side, it's 3x times half of, so is that just, what is that? I'm sorry.
9 minus 2x squared. Yeah.
So we're just that's just f of x. Sorry.
Yeah. I'm gonna
Or
write.
g of x. We just multiplying that by g of x. Okay.
Let's see.
And then, because the 4x is the derivative of g of x, right?
Yeah,
The
let me.
negative 4x is the derivative. Okay.
Sounds like you got it, but I could just write up
Okay.
instead.
Yeah.
So
Yeah.
yeah. So if you've got x is the root 9 minus 2x squared, so we put this as like 9 minus 2x squared. And then you said. So power rule is bring the half down and then don't touch what's inside and then take 1 away from the power.
Oh, okay. Okay.
And this is a negative. And that's the chain rule. Yeah.
Okay. Got it.
And then you also multiply with that derivative of the inside. This is a number, so it's going to go away. That's a derivative of negative 4x with power 1. Or just x.
Thank you so much.
Yeah, wish we had a full, huge whiteboard to make all this stuff fit. We'll make it work sometimes. It'll work out. Okay, let's try one more, and then that'll be that. So let's go. Oh, that's easy. This is pretty. Okay, this is a good one. It's not too bad. So, well, it's just going to be a product rule. Throw some extra numbers into it. So let's go with let's call the function k. K of x due to x cubed e to the x. Okay, I would make 2x cubed a function and then e to the x the other function and do the product rule. So this would be f of x. This is g of x. Derivative. Let's do the formula first. So f prime of x times g of x. You add, let's make sure. Second guessing myself now. Yes, we're going to add g prime of x times f of x. So maybe we could put some extra steps in here. We'll do the derivative with respect to x of 2x cubed is multiplied with e to the x, add derivative with respect to x, e to the x, multiplied with 2x cubed. That looks nice. Okay, power rule, 6x squared times e to the x. And then derivative of e to the x is e to the x multiplied with 2x cubed. I'm just going to leave it like that. So at our next meeting, we start chapter 6, and I want to go through 6.1, and your homework will start at 6.1. I think that the only concern right now is just getting your homework set up. I haven't actually posted any assignments yet. So please try to get a homework account. Let me know if you need help with that. And we're done for today.